So my hope with this lesson would be that we get through this kind of quickly, and then maybe take some more Chapter 8 questions at the end of today, or maybe just give you guys time to work. Like I said, we will finish wrapping Chapter 8 on Wednesday and take any other questions from Chapter 10. And then Thursday will be your Chapter 8 test, and Friday will be your Chapter 10 test because we have skipped Chapter 9 for the current time. Any other housekeeping questions? Happy Monday. How's everyone's weekend?
Pretty decent. Not really, actually. That's a false lie.
You adventured on your bike? Where'd you go? Yeah. Pretty funny.
I lost my key.
I'm sorry. I was wondering about your headwear this morning, but...
We had to get a discount.
Yeesh.
They just find it.
I'll give you my Skylanders one. Skylanders.
Alright. So, more work with exponents. So, the reason that I think that this lesson will probably be quicker is because we talked all about the multiplication properties of exponents. And when we multiply with exponents, so I want somebody to remind us, but we need to check if we remember what is a requirement and then what do we do. So when multiplying, when dealing with exponents, what is a requirement and then how do we deal with them? Caleb?
The requirement is they have to have the same base.
They have to have the same base. So what if I had like 3x squared and 4x to the fourth, but I had 3x and 4x, are those the same?
I'm not sure. I think it's fine because the base is the variable, not the number.
The base is only the object being acted on by the power. So, just trying to avoid mistakes before we get there. In the past, I've had people tell me, these bases are different. No, the base is only the x. So remember, this is like a string of multiplication. There's a multiplication here, and I can rearrange those however I want. So you can just make it 3 times 4 times x squared times x to the fourth. So then, same bases, what do we do? Strickland, might as well switch.
So, we multiply 3 by 4,
So deal with any coefficients or any not bases.
and then you get. Oh, alright. No, shush. Alright, then you add the 4 on the little left thing to the other 2 on the other left thing to get x to the 6.
Boom. So deal with any constant values that you can. Combine any coefficients that are possible. Add your exponents. So it's on your paper. But if you were to infer what we will then do with division. Any of you guys got your thinking caps on this morning? Carmen, you came in late, might as well involve you. We would subtract. So you have your properties here that show you 2 different methods. Remember, when there's a fraction being acted on by an exponent, the exponent distributes to both parts of the fraction, just like it would in, like, if you had addition or anything inside those parentheses. So this becomes 3 to the third over 5 to the third, and we expand both of those separately and then do the division and or simplification. Caleb?
How would you do it if there's an added coefficient? If it's like x to the power of 6?
Would it, so like x to the power 6.
Oh, over 3 to the 3x to the power of like 4, for example.
I'm going to go ahead and make this 3z to the power 4. Because otherwise, there's simplification that would avoid,
Oh, okay.
like, you know what I mean? I could have combined the x's, and that isn't what we want to do here. So, if we have this, then raised to a power union.
Yeah.
The power acts on my x to the 6, the power acts on my 3, and the power acts on my 4. It literally acts on every single thing that it can.
And then could you simplify that even more, or would you be stuck?
So this would become x to the 12th, 9z to the 8th.
And then would that be all you do?
I mean, we could make it 1/9 x to the 12th over z to the 8th, but aside from that, no. Yep.
So if they have different bases, then they well, not, I guess different bases.
Oh, yeah, there are different bases, X and Z. Yeah, so, I mean, you just expand it, or just, I mean, distribute it, really, is what we're saying, but you distribute it to every piece inside of there.
Okay, cool.
All right, so now we work with some rational exponent values, which we know rational exponents would actually, just to remind us and get us on the same page, we don't need to do this here. So you don't have to write this down. I'm just trying to remind us what this is. What's another way that I could write this not using the exponent? Michelle? Or at least not using this exponent. Sorry, let me clarify. Radical, the square root symbol? Yeah, it's radical.
Inside the little tail thing on the end, you do, what was it? I think it's 5.
So remember, numerator is the power that stays. Denominator is the root. So, second root or square root of x to the fifth. So remember, any rational exponents are really setting up like a root of a power. So if I have x to the 5/2 divided by x squared, let's evaluate that first and then simplify it out. So this would become x to the 5/2 minus 2, because I subtract the powers with each other, which becomes x to the negative 1/2, which then simplifies out to just be square root of x, because it's the second root of x to the first, and we don't need to write either of those. They are unnecessary. Try B on your own. We want to combine any like terms possible. Scarlet, what's my power for the m? Like just after my first step. Or tell me what you did. If this doesn't make sense what I'm going for, tell me what you did. Okay. Michelle? Where? You're like, it could be, you just need to give me a little bit more specifics then. So you're saying it's n over m to the power of 3, because if I just do my subtraction here, 2 minus 5 gives me, this is a negative 3, 4 minus 3 gives me a positive 1. So my positive values stay in the numerator, my negative exponents, to get rid of the negative, I just put that exponent or that value in the denominator. You have a face on.
Me?
Like, yeah, you're making like the...
Oh, no, I got it.
Okay.
My question was, so I just basically forgot to simplify even further.
Okay.
Would it be, I'm not sure if this would be okay, since I had 1/3, I guess 1 over m to the third times n. So
you had 1 over m to the third times n. That's fine. It's just not simplified.
All right, then you can simplify it even more.
Yeah.
All right, cool. Yeah, that's what
Yep.
Did you still count that as being correct like that?
It's correct, but not simplified. So I would write simplify. It's not wrong, but it is not done. You know, like, yeah, it's not like, that's where not using points is great, because I would probably put, see me. And when you walk up, you'd say, I know, I can combine these. You know, like that's where mastery comes into play. Like, you're not wrong. You're just not quite there yet. Try the got it. Our y values there. David, this one's coming to you. I'm just going by cards, not because you're eating Cheetos and talking to your friends, but that might.
No. He was asking me a question about a movie that we watched when we went out this weekend.
Does it have to do with math? What?
Well, you sound
Well, the
like
movie probably took a lot of math to me.
Oh, I'm sure it did.
Exactly, no, because he just started talking like in the movie.
Oh, that's right.
And
That's
then
right.
it sounds like what you're just saying.
Fear and Loathing in Las Vegas?
What? No, it's
What
the
movie?
we went to.
Oh.
When they're talking to the gym
That
coach.
movie's really dumb. I didn't say it wasn't funny. It's just really dumb.
Oh yeah.
That's
What
why
did you-
David!
That's why they watched it.
Hey, don't worry. I was very similar to those
Is
guys.
that why 1/4?
It would be wide to the 1/4, but still,
No,
that is not completely simplified.
Oh, I think I got it.
What is it?
The square, the forward root of
The fourth, put a TH on there, the fourth root of y. Now,
I'm getting a drink.
Alright, so why do we use these values? We talked a little bit about lab experimentation and different things like that. So, when we talk about population, way too big to deal with, right? Like we're talking scientific notation almost always. So, population density is people per space, right? Either per square mile or whatever else. Population density in some countries is crazy. Like people live on top of each other. Population density in other places, like in America, we have a lot of farmland, a lot of wasted space. So it brings our population density down. Well, space not utilized with people, with bodies. If you're talking about population density, that's like, you might have 5 people for 40 acres, like one family. Whereas in like China or those places, in like that much space, there's literally families on top of each other because they live in a high-rise building. Yeah, but they're like, but when you compare, yeah.
Like Canada.
Okay. So, in Angola, the population was 1.21 times 10 to the 7th. Remember that every exponent power in scientific notation is like decimal places. So to the 7th, we'd be dealing in what? Like millions, billions, trillions. What are we talking about here? Trillions, right? Because if it was 10 to the 6th, that would only give me whatever I start at. So once we get beyond 6, we're in the trillions. So tens of trillions, hundreds of trillions. The area was 4.81 times 10 to the 5th. Much smaller scientific notation. What was the density? So to find this, we got to take population over area. So set up population divided by area. Maybe 1.21 times 10 to the 7th. Divided by 4.81.
That's a lot of money.
And we know that our answer is going to come out to be people per square mile.
Wait, is that true? Well, you said that's trillion people, right?
If we write that out, so we're talking 12 trillion.
Trillion.
Or, sorry, billion.
See, you was right.
Yeah, my bad. I was 3 off.
I was wondering, like, how is there?
I forgot about the fact that the first 3 aren't any, like, yeah, thanks.
I was
Good.
describing that
Good
to Brian,
catch.
like, why, so my question was, how in the world is there 1.21 trillion?
Right, because the global population is only in the trillions. Is it only billions?
It's
8 billion?
7.8.
That was
Oh.
stupid.
12
What?
million.
Why are we so dumb, Calvin?
Yeah, it's Monday. My
I was close.
don't know what I was even thinking. There's no justification there. But either way, so we have.
You're like, it was 2 billion. I was like, wait, it was 8 billion.
So if you want to dissect my mistake, as soon as I counted 3, I called that million, which was like the first dummy move, and I just didn't. Yeah.
I also just assumed that there were a lot of zeros, so I assumed billion.
So how do I deal with this division? Back to like, let's just stop even trying to name numbers because apparently that's not working well today. Haven't we really? Brian, your card's up.
Sweet. Alright, so you then so then you do the whole 1 point. Alright, 1.21 and then divided by the 4.81. Yeah, and then you do the other one. And then you subtract the 10 to the 5th. Yeah.
So deal with your coefficient values first, then deal with your values to the exponents. So my 1.21 divided by 4.81 is going to come out close to a fourth. 0.25. Did you say 2515?
25,155.
All right, let's just go there.
Yeah.
Hold on, just a second.
That'll be 6.
What? Stop here. 6. So that's what we got out of our yellow. And just go ahead and write that decimal form. Out of my green, that one's easier. No calculator needed there. 10 to the second. To get this back into scientific notation, well, does it ask for scientific notation? No, we could just write it standard form now. Megan?
I was just going to say in the top it says dividing numbers in scientific notation.
Right, but once we get to our answer,
Yeah.
I can make my life
I
easier.
got 25 people per square mile because you can't have point something of a person.
Now, I agree, but still, depending on the math that we're doing, this is not talking about an actual 0.156 of a person. It's an average value. Right. But don't always say, like, I'm going to chop that off because it doesn't make sense. There's a lot of applications where we have to keep that there. Because then, what if we say how many people are there in 100 square miles? Well, now that 156 matters because that would give me an extra 15 people compared to if I had rounded it off. You know what I mean? So be careful with how much you round. My preference, if you are not asked, is to at least go to the hundredths place. That's good training for financial math. Financial math goes out to the pennies. Hundredths place, that's a good place to go.
What year is that?
Huh?
What year is that?
What year?
Yeah, what year?
What year would you take that?
Oh, I mean, it's kind of incorporated in all of them. You've already learned about financial math with simple interest and all that. I would advise you to take financial algebra up in the high school if you can. It is not required. It's one of the elective math choices, but I think it's really important. So if I were to have any say in what math you take, that would be my advice. Oh, yeah. I've been in support of that for a long time. All right. Avoiding me trying to actually say numbers. Try this on your own. Do the calculations on your own. Get all the way to the final answer so that you can make sure that you are doing this math correctly. Go ahead and write your answer in standard form. Rounding at the hundredths place. Minimum. You can go further if you want to, but at least get me out to the hundredths place. Make the warm fuzzies on there. Or did you buy them like that? We used to make those at church camp.
Wait, Mr. Hudson. I go to church.
We would make warm fuzzies, and I thought they were really, really hard to make until I made them first time. I know, you just wrap it and tie it in the middle.
Mr. Hudson, we were kind of confused. Does this class count as a high school credit?
You already have a high school credit right now, sitting in this room.
It's the math one.
Yeah.
Oh, because
This is the actual grade.
No, you have to
Got that
redo
one
it when you
I am not 100%
See, that was,
certain.
that's when I talked to Mr. Malley about it. We talked to him about, does this actually count as like this is
You
great.
get the credit. You have the credit. I don't think it applies towards your GPA.
That's what I was thinking.
Because it goes back to OHSAA. Because the athletic association has to have a GPA calculated on what you have done during high school. Like high school classes that you take before you get to high school give you credits, but not GPA. So your GPA for high school will start when you walk in the building as a freshman. You've already got credits, just no GPA. Does that make sense?
So it means we can get ahead in math, but the grades we took from those past math
Mhm.
classes won't actually apply.
So it's just gonna be harder for us to get
a
a
better
high
GPA.
GPA.
It should be easier for you to have success in math class.
No.
Yeah. No, in general, not in that specific class. I mean, in general, math is easier for you, right? So that's how we kind of even the playing field of if we want a math class that challenges you how it should, but that you could have success in, Math 3 at that point is going to be the right class for you. For other people, other peers of yours, Math 1 is that right class that will challenge them and still be able to have success. So it's not that it's harder for you, it's just different. That's different. We can play this game all day. What, Max, what'd you get here? Can I get any verification there for 169? Thank you. So, if we compare Honduras to Angola, Angola's population density is just over 25. Honduras is almost 7 times as dense with people. So, lots of things can go into that, like the fact that Honduras is a lot smaller by like a factor of 10. I mean, we could look at a lot of different factors that go into it, but if you were doing a comparison of population density, I mean, Honduras is almost 7 times as dense as Angola. Right, and like, but then, so say you were doing this as a global cultures question. What causes Honduras to have a higher population density than Angola? Maybe Honduras has more work, or there's like more prosperity, more, like maybe the weather's, like, you know what I mean? You could analyze this a few different ways of why is that. Yeah, I know. Honduras, it's just, I've heard they have good food there. Really? Very cool. When'd you go? Now applying a power to other powers, just like what Caleb was asking about. So this kind of takes us to the question that you asked about, a chunk at a time. So as we talked about, this power of 3 has to apply to each part in here. So this z to the 2/3 is getting multiplied by 3. And your 5 to the first power, that first power gets multiplied by 3 and just becomes 3. So I'm not going to write out the work for the denominator, but in the numerator, when I do this multiplication, it really just wipes out that fraction, and I get z squared over 5 cubed is
125.
Thank you. And that is all the way simplified. It's coming back. Yeah.
So, if you just had the z to the 2/3, like, so get rid of the 5 and get rid of the fraction.
Okay.
If you got rid of the parentheses, could you apply the 3 directly to the 2/3 and have the 2/3 be to a power so it would be multiplied?
Like that?
Yeah.
That's still a power to a power, so it would still behave the same as this is this, just using parentheses instead of another exponent, like notation.
But is there a way to raise an exponent to an exponent?
That's what we're doing.
Do it on the calculator.
This is a power to a power.
Could I have
So,
Flynn to the office, please? Flynn?
let's look at it a different way. So,
But be able to simplify it so that, like, if it was e to the power of 2 to the power of 3,
yeah, that's what literally I was about to write.
so that the 2 would turn into 8.
How would it?
If, like, so you can write exponents as, like, expressions, right?
Yeah, like 3 times 1 or 3 plus, like 2 plus 1 or what, yeah.
So would you be able to put an exponent in the expression that is the exponent and have it function normally?
You mean make this exponent like
On the 2.
3 plus, or no?
Just 3.
But you said an exponent in the exponent.
Well, like, is there a way to apply an exponent to the exponent and have it raise it to a power?
So you mean like the exponent of 3 raised again to another exponent?
No.
Because I think like you're just kind of asking a question that doesn't like can't be set up. This is an exponent to an exponent. Because what this is doing is if I have 2 z's 3 times, I will end up with 6
I
z's.
think Max showed me how to do it. Would putting the parentheses around the 2 and the 3 do
I'm
it?
sorry for the interruption. Could I please have Shane stump out to the office?
You just
Shane?
want to write what you're trying to like. I think I'm just not connecting with what you're trying to communicate.
That's a 3. Would that do anything?
Yeah, because now you're not raising z squared to the 3rd. You have z to the 2 cubed.
Okay.
So we're like, that is now, it's not an exponent to an exponent though. Right now when I look at just this, it's a constant to an exponent. That value will be an exponent. So either this as a whole is an exponent, or the only thing that is an exponent to begin with is that applied to the 2, then it becomes an exponent. But right now, you don't have z squared cubed, you just have z to the 2 cubed. Does that make sense?
I was just wondering if there's a way to make that work.
Yeah, except now you, like, order of operations, you have to do this first. Yeah. Sorry, I was confused at what we were asking. And that's actually easier than what we're doing because that doesn't involve any exponent combining rules. It just deals with how do you like power a number. Because that 2 cubed, we did that like a couple of years ago. And then there's no other work to be done. It would just be 2 to the 8, or z to the 8. So now when I simplify this out, so when we distribute this power, comes in here, and this is where things will get interesting. So Lynn, if we distribute this to the numerator and the denominator, what will my numerator become? So the power gets applied to both of them. Ooh, hold on, let's start at the top and go down. So what happens with the 4? Yeah, so my numerator becomes 16. This is where people make their mistakes. And it comes because you're doing so much work, your brain is kind of switching. You're like jumping from different files in your brain. Now when I do x cubed to the squared, how do those combine is what you have to think about. Close. That's when we have a power times a power. Here we have a power to a power. Instead of adding, we actually want to multiply them. So think of it like this. In the denominator right now, I have 3 x's, and then I'm going to square those 3 x's. Well, if I have 3 x's and I do that twice, I end up with 6 x's. Make it x to the 6th. So 16 over x to the 6th would be our simplified form there. Questions? You know, somehow my... Go ahead and try the next one. Somehow my center just got totally messed up. I don't know what made it mad. No, I don't think so. Not today. I was talking this morning with some of my classes about how this is really screwed up. I do not know what is happening. How on Mythbusters, they were looking at what affects how plants grow. And on one, they literally abused the plant. I don't know if you guys watched that, but it was interesting.
Like emotionally?
Yeah, like they were yelling at it, they were smacking its leaves. They were telling it that it was no good. Yeah, I'm not joking. Because they were doing a research study on does the environment of, like, essentially they were testing do plants feel. But so Has anyone seen this episode? So y'all don't think I'm crazy?
Of
Go
what?
look it up. Mythbusters. When
Wait.
they were trying to study, do plants feel?
Oh yeah.
Yeah, that's
I love
yeah. They did other control ones where they like just had like music going, or they had like wind chimes and nice like it's go look it up. It's interesting. Caleb,
Yes, sir.
question. Yeah.
Does the 3 go to the 2 as well?
Ah, so this is what Caleb had actually asked right before we like right at the beginning of the lesson. So now that we've done a little bit more setup, I'm gonna throw that to Caleb. Caleb, Carmen wants to know what all the 3 goes to.
So the 3 goes to the x, more specifically to the 6 in the x. It also goes to the 3. Sorry, it goes to the 2, and it goes to the y to the 4th at the bottom. So from this whole shit, we did it with the positive number. I actually shouldn't do it.
Yeah.
I honestly shouldn't do it.
I knew where you were going with that, but where you stopped is
Yeah,
this.
I was.
So Carmen, answer your question easily. Yes, it has to go to every single part because the 2 is separate from the x. This is really 2 times x to the 6th divided by y to the 4th. So, but the problem is that it's a negative exponent.
So what I was gonna say is that we do. Well, let's put it all in the simple form and then do this stuff. Do or. I see your or face.
Well, in my head, I'm thinking, what's the easiest option, right? I don't want to work any harder than I have to. What's the negative exponent tell me to do, Megan? I flip it. So if I want to get rid of my exponent being negative, just flip the whole thing, and this becomes y to the 4th to the positive 3, 2 to the positive 3, x to the 6th to the positive 3. Sorry, that's an exponent caret. And then this becomes, when I start simplifying,
Oh, can I say it?
sure, yeah.
Yay! Y to the power of 12 over 2. Well, I guess it would be 8 times. Is that 6?
Yes.
Megan, what is it? X to the. Thank you. Because Megan has it written down on her paper because she's done with it.
Okay, I couldn't tell if that was a 6 or.
But you should have it on your paper already, right? Like, gave you guys time to do it. It should be written down on there. So, apply that negative 2 to that entire expression here, a over 5b. So, in my mind, I would never actually write this red step. I would never even think about it. Immediately, I would flip the entire base, because right now this whole thing is the base for the negative 3. I'd flip the whole base, make my power positive, and then start the simplification process. So in my mind, this would become
I thought I found a pattern.
Ethan. What does this become? 25 b squared over a squared. Any questions? Any other questions about division with exponents? Now, I will tell you, this is the quote-unquote more difficult homework, but the easier one was just way too easy. I want to challenge you guys to try to get all of these done correctly. So you gotta pay attention to details, right, gentlemen?
Yeah.
You cannot be working fast or talking to other people and expect to do very well.
Right? Really? Okay, this time I say something.
I mean, you do a lot.
So I can grab my pen, and he looked up, and he put the spring in the pen, and he said it like this, and he just sat it. And when he took his hand off, he just fired the cap.
I think the moral of the story would be stop giving your things to other people.
I know, but